In this tutorial, we are going to be expanding on the previous application we developed, which was a clone of ChatGPT, and we're going to expand this clone in order to allow you to upload documents and have the ChatGPT interface talk about the document. So the first part of this is going to be developing a system to upload PDFs, in this case the Bitcoin PDF, and then what the second part of the system is going to do is to take that clone, and instead of asking general questions to ChatGPT, we're going to be asking more directly about the document that was uploaded. So essentially it's going to be reading the document for you to answer your question. And it's going to provide all the sources that it used in order to answer your question below in the front end. I'm going to be going through the code line by line and explaining all the important APIs we're going to be calling and libraries we're using. This is going to be a beginner-friendly expansion for the previous tutorial. Let's get started. We're going to get started right where we left off in the previous video, where we had a working ChatGPT clone where we can ask questions like, what is your name? And it's interfacing directly with OpenAI's API to read and answer our request. And to get to that code, I put both the installation instructions and the code starting point in the GitHub links above. Okay, so building off of that code, we're going to start with importing the necessary libraries for this. So we're going to go here where the existing libraries are, and we're not going to be deleting any of this, so we're just going to add just what we need. Great. So on expanding the application, we want to be able to load PDFs or text documents and have ChatGPT read and respond to the content of those. And we're just going to define a folder in our file system where we're going to be saving those documents. We're going to be taking this. Config is a library that we're using to access the .env file. So I'll show you that right away. But first, we're just going to grab that variable. And it's in the installation instructions, but env.copy. And in there, you're going to have index. And we're just going to define the folder where we're saving the PDFs to as save PDFs. Moving on, we are going to be importing and using the LangChain PyPDF Loader. So click on this link, we can see that LangChain imports a library called PyPDF. And what we're going to be using that to do is to read out a PDF that we upload and take the pages of it and ingest them into a list of dictionary or document objects, as shown here, where inside of the document object will contain the text of the PDF. This is necessary to allow ChatGPT to read the contents of our uploaded file. So looking at this code here, we're going to be using the Streamlit function file uploader, which presents a button to the front end that allows the user to upload a PDF. And that's going to be the PDF that the user is going to have ChatGPT read. And then we're going to, underneath that, include the ST button, which presents a button. And on the button being clicked, it's going to save the file that was uploaded into a temporary file, which will then be uploaded to LangChain's PyPDF Loader. And then using that loader, we're going to call the load and split function, which takes the PDF, splits it into an array of document objects that we can have ChatGPT interface with. Okay, let's add this to our code. And we're going to be adding this right above where we define the Streamlit containers that are holding the text conversation front. So we're just going to put it above where we usually would have our conversation. And then let's take a look at what this looks like. There we go. We now have a front end where we can upload files. So now that we've uploaded our pages, we are going to further split them into chunks. And we're going to be using the LangChain recursive character text splitter to do this. And what this does is it slides a window over our document. So we can see this being done here. So a window, say the red window, and it's going to grab all the text there and put that into a chunk. But it's not going to align the windows perfectly to each other. The next window is going to have a bit of overlap onto the previous window, and then it's going to take the text there and put it into its own. So we can see that the first window has the title and then a part of the abstract, and then the second window also contains that part of the abstract, but even more. And this is because we want to make sure that we don't cut off a sentence in the middle. And there's a chunk that always has a representation of a complete sentence because chunking is done at random. And the way we define our chunk size in this library, in this function, is through here. So we can have chunk size is going to be about 10,000 characters, and the overlap, meaning what is shared between each chunk, is 1,000. And these are numbers you can play around with to find the best chunk size for your use case. So we're going to apply this library, this function, and then we're going to use it to split the documents even further. So the pages is going to become page chunks. Let's add this right under here. So next we are going to embed our PDF into a readable vector using OpenAI's embeddings. And we can think of the embeddings as a way to relate text to each other. So looking at this blog post that OpenAI released gives us a great way to visualize this. So let's say our text is any of these. So these are all changing. And then we can take the text and place it through the embedding model. And what comes out is a vector. And a vector is a collection of numbers that each of them are used to measure a certain characteristic about what was embedded. And these are many numbers that is really long, that is not as interpretable to humans, but to algorithms, we can do useful things with it. So for example, what they did was they took all these texts, they threw it through an embedding model, and the vectors that came out, they placed it in a vector space here. And we can see that texts that are more aligned to each other or more like closely related group closer in the vector space. So we can see the texts here are all related to animals. So meow and like moo for cow. They were all grouped closely together versus a text that is related to sports, like a quarterback throws a football. And that's a general overview of what like vectors can help us achieve, which is how do we relate text to each other in a fast and intuitive way of a machine. So the first link introduces the general concept of embeddings, and the second one gives great use cases that you can use embeddings for. And the third link here is going to be explaining the library we're going to be using in LangChain to help us interact with vector embeddings. So the library is the Facebook AI Similarity search, and it's generally used to help search and cluster dense vectors. For our case, it does just what we need, which is trying to compare vectors to each other. And I'm going to showcase a couple of functions here. So using the FISS library, we're going to be using the from documents function. And we're going to be using this to create a vector store. And so we can think of the vector store as the list of the output vectors from each of the page chunks that we created before. So this function takes both the lists of page chunks, and it's going to take the OpenAI Embeddings API call. So the output of this is going to be our array of vectors. And what we're going to do with that vector is we're going to save it locally. And to do that, we're going to name this vector store as a PDF index. And we're going to be using the original file name that was provided, along with what we originally defined in the .env file, the index, which is just what is the folder we're going to be using generally to collect all of our vector stores. So we're going to be combining those together, and it's going to give us the local path. And then using the save local function, we're going to be saving the vector store that we just created to the local path so that it can be loaded once again when needed. And then finally, at the last step, we're going to save the PDF index to our session state variable. Let's add this in. So now what this is doing is when we press the button, we're going to take the file that we uploaded, place it into PyPDF Loader so that we can load and split it into pages, further split those pages into chunks, and then transform those chunks into vectors and an overall vector store using the OpenAI Embeddings API. And we're going to be saving that all locally. So this is what our front end looks like right now. Let's test out uploading a PDF. And the PDF we're going to be using is the Bitcoin PDF, which is the white paper introducing Bitcoin to the world. So I have that saved, and we're going to upload that here, and we're going to click index. And then great. If we look at our file stores, we can see that inside Save PDFs, which is the name of our index, we have Bitcoin, which is going to contain the Vectorstore. Just so that we can preserve uploaded PDF, we are going to, at the beginning, call PDF index equal to Bitcoin. So we will always be pairing our PDF index variable to Bitcoin, which is the name of our index for the file we just uploaded. So now that we have a vector store representing the text chunks of the PDF we just uploaded, let's update our ChatGPT completions API to use that. The most brute force method to do this would be to upload the entire PDF to the API every time we ask a question. So this is a little inefficient because, for one, it is going to be very expensive to upload the entire text. So there might be a better way to get around this by only uploading the relevant sections that the API needs in order to answer the question. And the way we're going to do this is we're going to embed the user's question into a vector. And then we're going to relate that vector to the chunks in the vector store that we just created, and only grab the top 2 chunks that are most related to the question and provide those chunks to the APIs for it to answer. Okay, so we're going to first take FAISS and we're going to load the vector store that we indexed before. So this is going to be calling it using the index and PDF index. And then we're going to be uploading again the OpenAI Embeddings library. It's going to be using this in order to turn the user prompt into a vector. And then the function that we're going to be calling now, this new function, is called Similarity Search. And what that is going to do is it's going to take the prompt, which is the question the user just asked. So for example, if we just ask a question like, what is this document about? When we click send, it is going to take that. It's going to become the prompt in this function. So we're going to take that and we're going to compare it to all of the chunks that we just embedded in the vector store. And those chunks is going to find the top 2 that are the most related to the user's prompt. And that's defined by k equals 2. So what gets returned back is an array of 2, and those are the 2 most relevant chunks to the entire vector store of chunks. And so now we're going to do a bit of prompt engineering, and we're going to provide this new instruction for the completion API. So this new instruction is going to be saying, use the information below to help answer the user's question. And it's going to then append the 2 top chunks, and page content is the text content of that chunk. So the first one, and underneath it, the second one. And then on the front end, we're going to, just for our convenience, write out what those 2 chunks were. So we're going to just use the stexpander function, and that's going to give a little drop down that we can use called source 1 and source 2. So we can see what the most relevant chunks were. So let's upload that. So let's comment out the rest of this, and let's actually show what is the most relevant chunk for a question. So going back to this, we're going to take our question, refresh the page, and given this question, what is this document about? We can see here that it is giving us the 2 most relevant chunks, and this first one is the first page. Great. So it's going to be grabbing the first page, and this one looks like a continuation of that. And so these are the 2 chunks that are going to be provided to the completions APIs to answer the user's question, which is, what is this document about? So let's continue building on that function. So continuing forward, we are going to now add the new role, which is going to define the role as a system and the instructions we have above here. So just use the chunks to answer the question. And then we're going to take the session state message, which is an array of what all the conversational history was. So it's the history of what the user said and then what the chatbot said. And in this case, we're going to first add what the user said. And what we're going to do is right under what the user said, we are going to add the instructions for the machine. So the system source help. We're going to do that in a different way than just adding it directly. So what we're going to do instead is we're going to create a copy of that array, and we're going to append the instructions to that copy so that the next question where it's not going to contain the context that is no longer relevant to the user's question. So let's add that. There we go. And then let's uncomment what we commented before, since we want to completely run this function now. And then the final instructions here is, instead of sending the array of messages, we're going to send our updated array, which contains our context. So let's update that right here. Great. Let's test it out. So a simple question: what is this document about? And there we go. It is now able to answer your question using the most relevant chunks from the PDF you just uploaded. We can also ask, what are sections 2 and 3? Just to prove that it is reading this document and not just relying on its memory. And so the sources have been changed. So now it's grabbing new sources from here. And it's using the sources to tell us that section 2 is transactions and section 3 is timestamp server. And let's check that. Section 2 is transactions and section 3 is timestamp server. So even though it is only providing a subset of the entire text, it is still able to grab the most relevant subset. Right now, we're serving two functions for the front end. That's a part on the bottom that's just responding to the user's questions, assuming that there's been a document uploaded, and then one on the top that is uploading a document. But we can split up the purpose of the application, and let's have a part of the application just for uploading documents and another one just for talking to a specific document. So the user could theoretically send a link to another person to talk with just a single document, and that person would not have to worry about uploading the document. It's already preloaded. So let's do that. What we're going to do is we're going to take advantage of the parameter experimental get query params, which is a Streamlit function that allows you to put parameters in the URL and have Streamlit identify those parameters and respond to them. The parameter we're going to put in the URL is going to be our PDF index. So that is what we've currently been hard-coded to be Bitcoin. So what this is doing is, if the URL has the parameter PDF index, it is going to load that PDF index into the session state so that it knows what Vectorstore to retrieve the context from to answer the question. So let's upload this. Put it right here. And then what we're going to define now is we're going to present either the file uploader or the chatbot, depending on if there's a PDF index or not. So what we're going to do is we're going to index all of the code for uploading the PDF and indexing that PDF into a vector store inside of this if statement, which is if the PDF index is not in the session state, ultimately meaning that the PDF index is not in the URL. And if it is present, then we're going to load the text box, the chatbot, so that we can start talking with that PDF. To change that, we are going to just take this part. So all of the indexer code, we're going to indent that forward so that we can add. And then we're going to take the rest of the code, which is defining the chatbot. We're going to indent that and place it under else. And then the final step of this is just this helpful link so that once there's a file that has been uploaded, we're just going to have a link that we can direct the user to start talking right away to the chatbot. And we're going to put this at the end of the uploading stage. Okay, let's test that out. Okay, great. So our URL has no PDF index parameter, so we can see it is just the uploader. And let's re-upload that Bitcoin PDF, index it, and what shows is the link to our URL, but with the PDF index parameter. So then when we click on that, our URL now has the PDF index parameter, and it is correctly showing the chatbot, so we can start asking our question of, what is this document about? There we go.